So, in the previous class, we were discussing about principal component analysis. The idea is to reduce the dimensions in data. Okay. Why to reduce the dimension in data? Because if we are having multiple features or dimensions, not every feature or dimension is relevant for us to put in modeling. Also, if we put features which are correlated collinear among themselves, so in that particular case we are going to get an overfitted model. All right, so we want in unsupervised, okay, machine learning algorithm, we want an algorithm which can reduce the dimensions, but it should reduce in such a way that the loss of information while dropping the features from the data will not affect or impact in our analysis. Okay, so for that reason, we decided to make principal components. Okay, so we did studied the basics of PCA in the previous class, and I shown you these cases where feature 1 and 2 are spread in such a way. In this, if we wanted to reduce any of the dimension, if we want to drop any of the feature, obviously it will cost us more. In the second case, if the distribution of feature is still not too high, but if we drop it in this, also we are facing a loss. So now we decided to make principal components. That means we want to orient access, and we want to transform our data over those axes, so that if we can get a component along which if I can have a data, so the percentage or the variance which has been shown by these features previously will be reduced, and those feature which are having obviously less variance with these principal components, they will have much more reduced variance. Okay, so I will be performing all the analysis over these components. I will reduce the features, drop the features. Okay, so the step number one, there are certain steps to perform the PCA, and these steps we were discussing in the last class. Okay, what these steps are? These steps are, your first one is the standardization of the data. Okay, and we did perform good discussion over it. Standardization, what does it mean, why to do the standardization? So it is a scaling process, it's a method of scaling in which different features in the data which are represented on different scales. That means some is represented in meter, some is represented in kg, or something else. Okay, so I want to make all these features over one scale. For that I need to make them standardized. For that, this is one of a method that is called as z score, by the help of which you can standardize the data. That means value in a column in that feature, every value that is present in that feature minus the mean of that particular feature divided by the standard deviation, that's called as a z score or the z value. Okay, so The reason, as I was explaining in the last class also, variables with high variance is gonna dominate the various variables with low variance. So that will result in the biased output from the model. So I want to give each and every feature equal weightage. So if they will be standardized and if their values will be present, every feature, those values will be present between 0 to 1, we will be having a good chance to perform the analysis of it without any biased nature. Okay. So in machine learning, standardization refers to the process of rescaling of the features, special input variables, of a data to have a mean average of 0 and a standard deviation of 1. As I am telling, between 0 to 1, we are trying to scale our data. This is also called as Z score normalization. So sometimes we say standardization and normalization are synonym of each other. So it's called as Z score normalization, and it is a pre-processing technique in ML. Okay. And we do scale our features and then we are going to put these features into model for training. Okay. So the main idea behind standardization is I want a similar scale in each and every feature. Okay. So whether you are using algorithms like support vector machines, k nearest neighbor, principal component analysis, these are distance metrics, distance based. Okay. So yesterday class आई टोल्ड कि लीनियर रिग्रेशन में भी हम स्टैंडर्डाइज करके दे देते हैं डेटा को. वी डिड परफॉर्म स्टैंडर्डाइजेशन एंड देन वी गिव देयर, वहाँ भी कर लेते हैं इन जनरल. ओके. व्हेन वी आर हैविंग अ डिफरेंट स्केल ऑफ द डेटा वी कैन डू. ओके. स्पेसिफिकली डिस्टेंस बेस्ड की बात हो रही है. दे आर टॉकिंग अबाउट दोज algorithms which do calculate distance of a point from other points. So obviously k means में, k nearest neighbor में, okay, distance calculate we perform. Okay. And according to the distance calculation we say that okay, these are the nearest neighbor or these can be a part of a cluster or a group. So or support vector machine also we do calculate the distance. Because support vector, what do you mean by support vector? In case of svm, this is the case, you are having a hyperplane, okay, which cuts or which divides class A from class B, and those points which are present at the boundary of the hyperplane, they are called a support vector, and we do calculate a distance of these points from the decision boundary. Okay, so this algorithm also have a concept of distance. So distance based algorithms में अब ये, this thing you have to fit in your mind that while performing implementation, either you can make a note. If you are sitting with your pen copy or whatever, you can make a note, okay fine, in pre-processing when we are using these algorithms. So data science and machine learning, now these are the things which we have to learn. That is called as an how much perfect you are concept building. ओके. एंड दैट्स द ओनली पॉइंट. हाँ, आई नो सर ये होता है, लेकिन कहाँ अप्लाई करते हैं, दैट्स द थिंग, एप्लीकेशन. इन दिस कंप्लीट कोर्स वी आर फोकसिंग अपॉन एप्लीकेशन. वी आर ट्राइंग टू लर्न द कॉन्सेप्ट्स. Okay. And the main thing is how to apply those concepts correctly in our code, in our projects. That's what we are learning. So when you are dealing with these algorithms, kindly apply scaling. All right. Now standardization process typically carried out this formula x minus nu by sigma. I already told you about this thing, value minus mean divided by standard deviation. Okay, this is a general formula for standardization. Okay. And then it's not only the thing which we can use for the scaling. Okay, that formula which I told you about, that is called as z score normalization or standard scaler. There are other algorithm or methods also to perform the scaling of the data. Okay. So these are min max scaler, robust scaler, unit vector scaling, and log transformation. Okay. So apart from standard scaler, which you have learned, the different techniques, for example, min max scaler. Okay, this method scales the features to a specific range, typically between 0 to 1. And the formula for each feature is x minus x min divided by x max minus x min. This is the way you can scale the data. All right. So if you want to transform the data between 0 to 1, kindly use min max scaler. Okay. In general case, we do say कि हमें positive values चाहिए, तो okay, we will checking the distribution of the data. इसको लगाने में, okay, we will see the distribution of the data also, how it looks like. इसमें positive value है कि नहीं है, या नेगेटिव वैल्यूज भी हैं. इफ इट इज हैविंग पॉजिटिव नेगेटिव बोथ है, तो कैन आई स्केल बिटवीन दिस टू दिस, क्या होने वाला है. ओके, तो ये देखना पड़ेगा कि वेदर दिस फीचर मे होल्ड पॉजिटिव वैल्यूज और नेगेटिव वैल्यूज और बोथ. अकॉर्डिंगली वी विल अप्लाई द स्केलिंग. ओके, ये भी सोचना पड़ता है थोड़ा इसके बारे में. So if you want to scale the values between 0 to 1, min max scaler is used, and this is the formula for it. Value minus minimum of the value in that column, maximum of the value in that column minus minimum. Okay, it is used when the features are skewed distribution, या तो left skewed होगा या right skewed होगा, then we are going to, तो तभी मैंने बोला distribution check करना है पहले. ओके, इसकी स्क्यूनेस चेक करिए आप डेटा की, देन यू आर गोइंग टू अप्लाई मिन मैक्स स्केलर. तो डेटा विजुअलाइजेशन वी डू, we prepare histogram या dist plot. So while preparing histogram or dist plot, we can understand how the orientation of data is, and if you know the orientation of the data, accordingly you can apply the scaling technique over it. Your next scaler is robust scaler. Okay, unlike min max scaler, the robust scaler uses IQR, interquartile range. And robust scaler specially used for outlier. It is sensitive, it is less sensitive to outliers. That means the formula here is x minus median of x divided by IQRx, interquartile range. That I will explain ahead. IQR, what it is. Okay, that's called as interquartile range. Okay, IQR, and you are having this box plot. When you make a box plot, so this is Q1 first quartile, this is Q3 third quartile, this is Q2, that's called as a median. And IQR, what is IQR? Q3 minus Q1, this is IQR. This is interquartile range, this distance. Okay, that's called as an interquartile range. So that's what it is saying. Robust scaling is less sensitive to the outliers. Okay, and the formula for robust scaling is x minus median x upon IQR. So if you are having outlier in the data, you are applying robust scaling, robust scaler. Okay, outlier or not out, what you think? Whether you are having outlier in the data, then you are applying robust scaler, or when you are not having outlier in the data, then you are applying robust scaler. What do you think? It is less sensitive to outliers, means outliers are not going to put an impact here over your scaling technique. Okay, so in this case, obviously when you are having outlier in your data, and this scaling technique will make it less sensitive, you are going to apply the robust scaling technique. Your next scaler is unit vector scaling, normalizer. Instead of scaling based upon the summary statistics like mean, standard deviation, this method scales each data point so that resulting vector has a length of 1. So unit vector, so scale everything. Sabko, all the vectors will be scaled to unit 1. Okay, so it's often used when the direction of the data is more important than the scale of the individual features. So direction is important, तो वहां पर हम unit vector scaling नॉर्म कर देंगे. Okay, scale to 1. Each vector should be made of length 1. That's called as a unit vector scaling or the normalizer. We are going to use less here. Okay, less use करते हैं. Okay, in general we use standard scalar. Okay, then we use min max scalar, then we use robust scalar depending upon your problem statement. We are having one more thing that is called as log transformation. Okay, when your data is highly skewed, okay, then we apply log over that data and convert it into normal form, normalization, normal form में convert कर लेते हैं. It also reduce the impact of outlier. Okay, so we do apply log over the data, log of the features. Okay, so that will help in converting your data into normal form, and it will reduce the impact of outlier. Very important thing this transformation is, क्योंकि when we are going to study linear regression, तो उसके अंदर एक requirement है. Okay, norms है उसका. While using linear regression, the linear regression say that all the features should be normally distributed. वो बोलता है ऐसा. Okay, then you put this data into the linear regression model. उसका rule है एक. Okay, so when we are going to make the visuals of each and every feature present in the data, and we see whether they are normally distributed or not, तो normal distribution का plot ऐसा बनता है ये. This is like a normal distribution. Okay, or if your data is skewed, skewed यानी कि ऐसा है, whether it is left skewed, whether it is right skewed. Okay, so by applying log transformation, okay, it can tackle the skewness of the data. Highly skewed data को tackle कर लेगा. वैसे तो robust scaling भी है. Robust scaling also, um, it's less sensitive to the outlier, ये है. And min max scaling जो है आपका skewness को ये भी deal कर लेता है. But log transformation is much more better when you are going to deal with highly skewed data and also impact of outlier. So impact of outlier, min max, sorry, robust scaler से आप tackle कर लोगे. Skewness you are going to tackle with the help of your min max scaler again. ठीक है, min max से you are going to tackle the skewness, and robust scaling से you are going to tackle the outlier. But इन दोनों की facility आपको log transformation में you are going to get, and we do apply log transformation in linear regression. We do that. Okay, करते हैं. Then only we are going to put the data into the model for training purpose. All right, so that's why it is important. So we did study this part, your standardization in the data. It was very much mandatory for me to explain you, because this is one of the pre-processing step, and we do apply this pre-processing over many of the data. Okay, as per the requirement. Now the step number 2 is covariance of the matrix. I did explain covariance. That means if you are having a feature x, y, and z, then the variance among each other. Okay, x and y. Okay, so how variables are varying with each other, that means how they are behaving among each other, that is called as covariance. Name itself says na, co means corresponding to one another, so that is called as covariance. And variance, I already told you in the previous class, variance actually it's a distribution of the data. Okay, and in terms of your formula, it has been said that okay, distance of a point from its mean, that is said to be variance. Okay, so that is said to be variance. Fine, so here we are calculating the covariance among the features. Okay, so this is your step number 2 to perform principal component analysis. Okay, step number 3 is computation of eigenvalue and the eigenvector. Okay, so these terms we did studied in our previous lectures, and there also I told it's very much important because we are going to apply in an algorithm. So the concept of eigenvalue and eigenvector said AV equal to lambda V, where A is your square matrix, V is an eigenvector, lambda is an eigenvalue. Okay, and this is how we do explain via equation. And व्हाट दे मीन। सर ये क्या है, ये क्या करते हैं? आइगन वेक्टर जो हैं आपके, ये प्रिंसिपल कंपोनेंट्स हैं। ओके, यू आर ऑलरेडी अवेलेबल डेटा, okay, in your space, already available. Now I want to show that data along some different axis. Okay, so that different axis will be represented by your your what, eigen vectors. There is one question which has been asked here, sir, what is the standard deviation of the variance of variance is the distance of a point from its mean. Okay, so what is the relationship between variance and the standard deviation? What is the relationship? Variance equal to standard deviation ka square. This is how we write. And standard deviation equal to square root of variance, isn't it? What we have studied in statistics in general. Is this the formula? Am I right or not? Variance is equal to standard deviation square, standard deviation equal to square root of variance. Is it or not? Tell me, am I right or not?
Yes, sir. The question is like logically, how can you define that? Like, if pictorially, if you're seeing, showing, how can we define that?
Okay. See, both are technically the same concept. Both are showing the distribution of data only. Okay. Only the difference is when the variance is high, it's better to take a square root of it and let us say कि वो standard deviation है. So only that's the way we are seeing. Okay. Just like in case of evaluating our model for regression, we are having mean square error, we are having रूट मीन स्क्वायर एरर ऑल्सो सर, ये भी है हमारे पास, आरएमएससी भी है हमारे पास. सो वी डू फॉलो एमएससी, मीन स्क्वायर एरर. Okay, so why the concept of RMSE came into the picture? The reason is if your error is high, तो सर हम उसका रूट कर लेंगे, विल कैलकुलेट द रूट ऑफ इट. तो ये जो हाई एरर है, इसको आई कैन रिप्रेजेंटेड विद आरएमएससी इन लो, मतलब उसको लेस वैल्यू पर हम शो कर सकते हैं. दैट्स द कॉन्सेप्ट. बाकी बोथ आर representing the same thing. Is that okay, sir? Or do you have anything in your mind? You can say.
Yeah. Like what I have to say, like whether we are calculating the variance first, right?
Yes.
And after that only we are calculating the standard
Sir,
deviation.
standard deviation. Sir, if the value of variance is high, okay, so we can take the square root of it and we can say that, okay, this is the standard deviation. Standard deviation. So, deviation means what, sir? Deviation means we are going to find the distance of a point from its mean. That is called as a deviation. यही बात है ना सर, deviate होने का मतलब तो यही है सर, distance of a point from its mean. ओके, सो स्टैंडर्ड डेविएशन भी मीन तो हमारा बदला नहीं है. वी आर हैविंग द ऑल द पॉइंट्स एंड वी आर हैविंग अ मीन. तो मीन हमारा वही है एंड वी आर कैलकुलेटिंग द डिस्टेंस ऑफ इट. ओके, तो व्हेन वी आर,
Sir,
हाँ यस,
yeah, one more understanding I have to get. Like, for example, if I take square root of 16,
हाँ 16,
that is
yes,
equal
it's
to
4.
4.
हाँ हाँ
4.
हाँ
That is 1 by 4th of 16.
हाँ, 1 by
And if I
4 of
take,
16.
25, I take 5, that is 1 by 5th of 25.
1 by 5 of 25, yes.
So similarly, if I take square root of variance, if I take square root of variance, this is 1 by what the value of that variance will be the square root, right?
Will be that, yes, obviously square root of that particular value.
Okay, so
And
having a huge difference between that both,
that
right?
that will be huge difference between that. Okay, and sir, in real terms, if I would say, the distribution of data is very much high. Okay, so in order to interpret it, we do consider standard deviation. We do consider
Okay.
that, okay, fine, let's take the standard deviation of the values and put it into the formula and calculate the results. Okay, and standard deviation plus minus. One more thing, sir, I want to add here. Okay, instead of variance, technically, we do put standard deviation only. For example, I explained you here normal distribution. I can say more things about it when we are going to talk in statistics. So, for example, we are having a normal distribution. In case of normal distribution,
Yeah.
if you are say, sir, mean, मीडियन, मोड, ऑल आर सेम, तो उसमें वो वेरिएंस की जगह स्टैंडर्ड डेविएशन पुट करते हैं. व्हाट इज द स्टैंडर्ड डेविएशन? बिकॉज वी वांट टू शो दीस distribution of the data in a minimum range. Sir, मतलब मेरा ये point of view है. You told कि sir 16 का square root we got 4. 25 का square root we got 5. तो सर हम हमारे पास there is a huge difference between these values, sir. These are very less values. And actually में variance तो 25 और 16 था. ओके आपने उसे 4 and 5 you did represented. तो क्यों करा ऐसा? Because the point is, sir, as we already studied above, standardization है ना, ये पढ़ा हमने. एंड व्हाट इज द रोल ऑफ स्टैंडर्डाइजेशन? ये मिनिमम वैल्यूज पर रिप्रेजेंट करना डेटा को, मिनिमम स्केल्स पर रिप्रेजेंट करना डेटा. अब यदि आपका वेरिएंस बहुत बड़ा है, ओके तो मेरा मोटिव ही उस वेरिएंस को स्टैंडर्डाइज करने में लगा. माय मोटिव इज टू मेक दिस वेरिएंस स्टैंडर्डाइज, यही मेरा मोटिव था. तो रेदर देन इंटरप्रेटिंग हाई वेरिएंस, लेट्स कन्वर्ट इट इनटू स्मॉल. स्मॉल मैं उसको कन्वर्ट कर दूं, सो दैट्स व्हाई जस्ट टेक अ रूट ऑफ इट. ओके तो उन्होंने जैसे दैट्स व्हाई आई टोल्ड ना, एमएससी एंड आरएमएससी, इफ यू आर हैविंग मीन स्क्वायर एरर वैल्यू वेरी हाई फॉर अ रिग्रेशन, सो देन आप इसका रूट करके यू आर गोइंग टू टेक स्क्वायर रूट ऑफ एमएससी, दैट विल बी आरएमएससी. रूट मीन स्क्वायर एरर, यही उन्होंने बोला है जवाब में. ओके टेक द रूट ऑफ इट. तो सिमिलरली मैंने रूट करा वेरिएंस का, तो मुझे स्टैंडर्ड डेविएशन मिल गया.
And sir, one more thing I have to add you, like as you say in the normal probability curve. So the first variance, like there is a first standard deviation that is almost 66% data lies there, right? One plus I think
yes.
1 sigma, 2 sigma, like that way we'll be
1
adding in
sigma,
there,
2
right?
sigma, yes. Okay, and sir,
So
we instead of, as I told na, instead of variance, we do use standard deviation only in the formulas. In our all distribution formulas, we use standard deviation only, not the variance. We use mean, we use standard deviation rather than the variance. ये use करते हैं. Okay, or whether if I do say about what is the formula for normal distribution, so the formula for normal distribution is something like this: 1 upon square root of 2 pi and e की power minus x minus nu का and 2 sigma का whole square something. This is certainly a formula for normal distribution. You can verify कुछ यदि changes होता है तो. Okay, so ऐसा ही दिखता है वो formula. So here instead of variance now we are using standard deviation.
Okay. So it will have all the property of the variance.
हाँ
Standard
also
deviation will have all the property.
सर वहीं से बना है सर, ये बना वहीं से ही है. Obviously it is having a property of variance. Okay, so yeah,
Sure.
so very important discussion related to the standard deviation and the variance, and we are going to cover it again in our statistics part. Right now I'm having AV equal to lambda V. V is my eigenvector. Vector means this is the principal component. ये जो vector है यही component है, इसी के about I need to project the data. And eigenvalue is कितना करना है, how much if I'm going to project the data, how much information I'm going to get collecting from it, how much information I can collect from it, that is called as a variance. Okay, variance. Okay, कितना मुझे information वहां से मिलेगा, how much variance is explained, that is called as an eigenvalue. Percentage of information explained, that is called as a variance, that is represented by eigenvalue. तो vector पर vectors बनाने हैं मुझे, I need to find it actually. I need to find the eigenvector, and the complete process, the numerical, you have already done for eigenvalue and the eigenvector. Okay, what you did, देखिए, let us suppose A is any square matrix. Okay, and here we will put covariance matrix, the matrix which you have calculated from above, covariance. So we are going to use covariance matrix for the calculation. Okay, so first standardize your data, second calculate the covariance, make a matrix, and then use eigenvalue and eigenvector concept. Okay, so let us suppose you are having a x as an vector. Okay, we are selecting as 1 1 1 ऐसा करके they selected. Okay, something like that. Okay, and ये आप मान के चलें, ये आपके पास एक स्क्वायर मैट्रिक्स है. Okay, that is an covariance matrix. You are having a vector AV equal to lambda v, something like this. Okay, so lambda is 3. This is your vector 1 1 0, ये आपका वेक्टर है. दैट मीन्स 3 टाइम्स ऑफ द सेकंड मैट्रिक्स, समथिंग लाइक दैट. अभी ऐसा लिखा है, हम तो पूरा सॉल्व कर चुके हैं. इट्स नॉट इन मतलब नॉट एन इशू फॉर अस. वी विल सॉल्व इट अगेन, विल डू इट अगेन. ओके, तो कर ही लेते हैं, कोई इशू नहीं है. Whatever the steps for eigenvalue and eigenvectors for the calculation we performed, first thing is you should be having a square matrix. So here we are taking a कोवेरियंस मैट्रिक्स, ठीक है, स्क्वायर मैट्रिक्स है वो, ठीक है. Then you have to corresponding to this, we are going to put into this formula a v equal to lambda v. This is your formula for eigenvalue and eigenvector. आप just move it here. So av minus lambda v equal to 0. ठीक है, ये करा. Then they are saying take v common from here. So a minus lambda v equal to 0. I need to multiply lambda with identity. So a in v equal to 0. That's what I did. Then what next I need to do? What next I need to do? Let us consider this as a square matrix. Minus 4 minus 6 3 5. ठीक है. Then you are going to solve the characteristic equation. Okay, I hope you remember this thing. We are going to solve a characteristic equation. A minus lambda I. Okay, ये निकालना है हमें. तो ये आपका मैट्रिक्स है, दिस इज योर आइडेंटिटी, ये आपका लैम्बडा है, स्केलर वैल्यू है. ओके, जस्ट मल्टीप्लाई इट इनसाइड. Okay, subtract it from this matrix, you are going to get this as a result. Okay, then calculate its determinant, put it to 0, you are going to get the values of lambda. They will be called as a eigenvalues. This is your equation, quadratic equation. And when you are going to solve it, you are going to get the value of your eigen. Okay, so here we are getting lambda equal to 2 and minus 1. These are the two values of eigenvalues, 2 and minus 1. Then you are resubstituting these values, 2 and minus 1, into the equation. You have to resubstitute this thing. Okay, first you are going to substitute 2, second you are going to substitute as minus 1. Okay, I have already covered this topic in my previous classes. There I have already solved the complete eigenvalue and eigenvector this concept. Okay, so whatever be the values of lambda you got, again put it here. Okay, so you are getting mv equal to 2v, and one you are going to get mv equal to minus v. These two equations you are going to get. Okay, and then you have to solve it accordingly. Okay, you have to solve it accordingly. Fine, just put the vectors here and values, and you will get कि क्या vector मिलने वाला है मुझे. Okay, what I'm going to get. Okay, so we have already solved this thing in the previous lecture. Okay, so हुआ क्या, what happened from this step, from this step we got eigenvectors, we got eigenvector, and we got eigenvalue. That means now अब आपसे बोला गया कि you have to prepare a principal component, you have to make a principal component. So principal component, it's not certainly na कि you can make from your own side कि सर दिस इज योर डिस्ट्रीब्यूशन ऑफ द डेटा, चलिए सर ऐसा बना देते हैं. अपने मन से थोड़ी ना करना है. Okay, not from our own choice, we have to do something mathematically. Okay, to make the principal components. Okay, जहां भी वो आ रहे हैं, and accordingly we are going to project the data over it. ऐसा करना है हमें. So I got the vectors from here. Okay, I got the there are multiple eigenvectors available to each eigenvalue. Whatever be the eigenvalues you are getting, as much as eigenvectors you are going to get. For each eigenvalue you are going to get an eigenvector. That's what they are saying. Multiple eigenvectors are available for eigenvalues. Okay, so after that, eigenvectors of the covariance matrix are the direction where the most variance explained, where most variance is explained. That means if you are going to put these vectors over, that means you are going to put these vectors over the data. Okay, या तो ऐसा बोलते हैं हम, we are having the thing is कि sir, either I need to project my data over these vectors, project data over these vectors, That means your data is already presented here in this format. Okay, now you got these vectors like this, so kindly project the data over this, project it. Or or sir, where we are going to make this is your data present. Okay, so just make principal components here in this way. This is PC1 and PC2, something like this. Just make principal. So what the things are, अभी पढ़ते हैं क्या होगा. So अभी ये बोला कि eigenvectors of the covariance matrix are the direction where most variance explained. Okay, most variance is explained, and eigenvalues are the coefficient, that means percentage or the amount of variance, percentage of the information what I got along this direction, that is represented by the eigenvalue. Okay, so this is your step after calculating the covariance. You are going to find eigenvalue and the eigenvector. तो ये vectors मुझे निकालना है जहाँ पर data I need to show. Okay, yes.
Excellent. Yeah, I have a question, sir.
Please tell
It's like, yeah, the eigenvectors here just plotted is the place for having the highest
me.
variance.
Highest variance,
So,
yes.
we will have an axis over there, which is a principal component axis.
Huh.
Axis will be drawing.
Huh.
So, what about the other points that is very close to mean?
What are other points which are very close to mean? So
Yeah.
if the points are very close to mean, sir, obviously their variance will be nearly zero. Their variance will be nearly equal to zero if they are closer to the mean.
No, no, sir. I'm asking like, we have drawn a principal component through
Huh.
the area we're having maximum variance. Now,
Maximum variance,
so
yes.
in normal probability, a vertical line will be the mean.
Hmm.
So that there will be many points that is close to the mean,
Closer to the mean.
right? So will you be projecting these points to the principal component,
Huh.
principal axis?
That's what we are looking forward to do. Okay, that means
Okay.
how we are going to transform. We are still left with some of the steps to perform.
Okay.
We are not over,
Okay.
sir, right now.
Okay,
Okay,
sir.
this is
Okay,
one
sure.
of the steps which we did. We are still need to do some more steps. Okay,
Sure,
but
sir.
but but
Thank-
but right now I have one more thing to explain. That is covariance matrix. How to calculate it? Because you are going to apply eigenvector and eigenvalue concept over covariance matrix. Okay, so now the question is, sir, how to calculate a covariance matrix? Okay, so let me explain you. It's a very simple thing. It's very simple. Let us suppose the number of variables determines the dimension of the variance of the covariance matrix. Number of variables means the number of dimension. Okay. Let us suppose I am having two variables or two dimension in the data set. Okay. One is maths, another is science. Two features I am available in the data. Though, and these they are representing the subject. Okay. Three students I am having whose marks are recorded here in maths and science. Okay. Now, it's quite clear that you are having x and y as two features. Okay. I need to calculate the covariance. Okay. So, how you can calculate the covariance? According to my covariance matrix formula, how we are going to organize the data here, it's been written as in this way: covariance of xx, covariance of xy, covariance of yx, and covariance of yy. This is how for two variables we can write. Okay, fine. So this will be my matrix: covariance xx, xy, and yx and yy. One more thing I want to say: covariance of xy and covariance of yx. These two are same thing. Okay, there is no difference between them. Whether I'm going to talk about the variance corresponding to x to y or whether y to x, both are same, है ना? Different नहीं है ये, same है. हाँ, covariance of xx means variance of x and covariance of y means variance of y. Now, so this is the data with x and y, two features. What to be done next? What are the steps of calculating covariance? Let me proceed. Step number one: find the mean of variable x. Okay, so mean निकालना है. 92 plus 60 plus 100 divided by 3 mean. This is done by dividing. Okay, ये तो पता है हमें. सब्ट्रैक्ट द मीन फ्रॉम ऑल द ऑब्जर्वेशंस, ये वेरिएंस हो जाएगा. Subtracting mean from all the values, so 92 minus mean is 84, so 92 minus 84, 60 minus 84, 100 minus 84, ये variance है. Okay, then take the sum of the squares of the difference obtained. So whatever be the results you are getting here ना, उन सबका square कर दो and take the sum of it. Squares and then take the sum. कर दिया. Then divide this value by 1 less than the total. We get the sample variance of the first variable x. So sum of the squares divided by total number of values, total number of entries. These are 3 because we are having 3 students. So 3 minus 1, that will be 2. So ये कर दीजिए आप. The answer is 448. So ये variance आ गया. This is the variance, sample variance. Sample है, sample variance. There are two things, population or sample, that I will teach you in the statistics. Okay, so population is an universal data and sample is a part, it's a subset of that universal data. So let us assume अभी एक sample data है मेरे पास, 3 students का ही है. Okay, and this is the way you are going to calculate the variance of x. Similarly, you can calculate the variance of y. Similarly, repeat all the steps same for y. Okay, calculate the mean. Okay, subtract the mean from each and every value present here. Take the sum of the squares of it and divide it by 2. तो y के लिए भी we did the same process. ये हो गया y के लिए. Repeat. So the variance of y is coming as 700 and the variance of x is coming 448. So ये तो वेरिएंस है ना, मुझे तो कोवेरिएंस निकालना है. आई नीड टू फाइंड कोवेरिएंस. ओके, अब क्या करना है? नाउ चूज अ pair of variables x and y. That means choose a pair of variables x and y. That means 92 80, 60 30, 100 70. Pair है ना, pair of these variables x and y. I need to take them. फिर क्या करना है? Subtract the mean of the first variable x from all the observations. That means 92 minus 84, 60 minus 84, 100 minus 84. So x का हमें पता है 84 is the mean. Okay, subtract 84 from each of the value. Similarly, y का भी mean I know, y का भी mean I know. Okay, उसको भी subtract करना है. The mean of y is 60, for example. Mean of y is 60. इसका 60 है. So 80 minus 60, 30 minus 60, 70 minus 60. Okay, ऐसा करना है. Okay, and then multiply corresponding observations. That means 92 minus 84 into 80 minus 60. तो भाई इस वैल्यू में से इसका मीन सेल्फ का ही खुद का 92 minus 84 मल्टीप्लाई बाय 80 minus 60 प्लस 60 minus 84 multiply by 30 minus 60 plus 100 minus 84 multiply by 70 minus 60. तो करस्पॉन्डिंग वैल्यूज का ही आपको क्या करना है? मल्टीप्लीकेशन यूनिट टू परफॉर्म. अच्छा, ये कोई डिफरेंट नहीं है वेरिएंस से. इन वेरिएंस ना यू आर कैलकुलेटिंग द स्क्वायर कर रहे थे, आप स्क्वायर कर रहे थे, देन सम कर रहे थे. यहां स्क्वायर नहीं ना करते हुए यू आर कैलकुलेटिंग द multiplication of the corresponding values instead of square. Okay, so subtract the value from the subtract the mean from the values and multiply each of them. ये करने के बाद okay, after doing this thing, ये करा. Okay, multiply these and add these values and divided by n minus 1. यानी obviously 3 minus 1 और 2 ही होगा, divided by n minus 1 यानी कि 3 minus 1 that is 2. So ये रहा 520 आंसर आया. बस यही कोवेरियंस होता है, कोई ज्यादा टेंशन नहीं है. इट्स वेरी इजी थिंग टू कैलकुलेट कोवेरियंस, वेरी इजी. ओके, सो ये आपका कोवेरियंस आ गया, तो एक्स वाई का आ गया या वाई एक्स का आ गया, भाई हमें क्या, कोई एक ही बात है, वो तो सेम थिंग। ओके, तो अब बचा क्या, पुट दीज वैल्यूज इनटू द मैट्रिक्स, covariance matrix. So what is the covariance matrix? Covariance of xx, covariance of xy, covariance of yx, and covariance of yy. So covariance of xx is equal to variance of x. What is the variance of x? Variance of x is 448. Okay, so put 448. So 448. Covariance of xy is 520. 520. Covariance of yx same 520. There is no change. 520 होगा वो. And covariance of y is variance of y. What is the variance of y? Variance of y is 700. Okay, so put 700 here. ये आपका स्क्वायर मैट्रिक्स आ गया, इसी का आइगन वैल्यू आइगन वेक्टर निकालना है. ओके, you have to calculate the eigenvalue and eigenvector for this thing. Fine. Okay. Yes. Any doubt? Please let me know. Yes. Yes, Anil sir. Please ask the question.
Sir, you are taking that difference, then you are multiplying it,
हाँ
sir.
sir.
Some
Yes.
differences are,
हाँ.
in that case, what we should do, sir? Will
Uh,
it sign matter?
sir, sign. Yeah, we are first calculating the difference. Okay, and then we are adding them. That's what we are doing.
मल्टीप्लाई करेंगे नहीं
हाँ
सर,
सर, मल्टीप्लाई
दोनों
करेंगे.
का
हाँ सर, यस, दोनों का डिफरेंस वी
मल्टीप्लाई
आर गोइंग टू मल्टीप्लाई. Then we are going to take
मल्टीप्लाई
the sum of each and everything. Then we are going to divide
हाँ
it by 3 minus 1. That means n minus 1. That's all.
सर, इफ नेगेटिव नंबर्स आर देयर सर,
हाँ,
इफ दिस
चलेगा सर, कोई इश्यू नहीं है, हो
रिजल्ट इज
सकता है.
नेगेटिव नंबर,
अ,
चलेगा सर?
हाँ,
हाँ
चलेगा
सर,
सर, हो
ओके
सकता.
सर, फाइन सर.
वैसे
लेकिन फीचर तो नेगेटिव नहीं रहेगा नहीं
फीचर
सर?
नेगेटिव नहीं,
दैट
नहीं, 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 नो, नो, नहीं होगा.
हाँ सर, ओके सर.
ओके, वो
हाँ
नहीं
सर,
होगा.
थैंक यू
ओके
सर.
सर, वी कैन हैव वैल्यूज करस्पॉन्डिंग टू दैट. लेकिन सर एक बात है, वेरिएंस भी, वेरिएंस इफ इट्स ए नेगेटिव वेरिएंस का कॉन्सेप्ट क्या हो सकता है सर, इफ आई से, यदि वेरिएंस वी डोंट हैव एनी नेगेटिव वेरिएंस कॉन्सेप्ट, सो हाउ वी कैन हैव अ नेगेटिव कोवेरिएंस. मींस ये क्या बताएगा, ये क्या बताने वाला है वो. अकॉर्डिंग टू आवर डेफिनेशन, कोवेरिएंस मींस हाउ द वेरिएबल्स आर बिहेविंग करस्पॉन्डिंग टू ईच अदर, व्हाट इज द बिहेवियर अमंग देम. तो यदि आप नेगेटिव बोल रहे हो, फॉर एग्जाम्पल हम बोलते हैं नेगेटिव, सो क्या क्या बताना चाह रहा है, मतलब व्हाट द आंसर इज गोइंग टू टेल अस, योर कोवेरियंस between the feature x and y is negative. What does it mean? What does it mean?
They are totally in diverse
इन
sort of a
डाइवर्स.
thing, sir.
हाँ, डाइवर्स, हाँ, नेगेटिव तो एक साइन या डायरेक्शन, बिल्कुल सही कहा आपने सर, यही बताता है. सो इफ वन इज इंक्रीजिंग अनदर इज डिक्रीजिंग इन द अकॉर्डिंग टू द वेरियंस, दैट्स व्हाट द थिंग इज. That's what the thing is. कहीं ऐसा तो नहीं है सर, if we are having y equal to 1 upon x, okay, and x and y are the two features which are present in our data, okay, something like this. ऐसा कुछ है तो x is decreasing, so y is
Yes, sir.
increasing. So is the negative sign showing this kind of thing, this issue, okay, or something else? Okay, तो ये just make a star over it. We have to. Okay, I request other people also to think over this concept, because नेगेटिव वेरिएंस वाली बात, नेगेटिव वेरिएंस में अच्छा एक चीज और है, नेगेटिव वेरिएंस. हाँ, तो सर ऐसा तो होता ही है ना, ऐसा इट्स जो है इट्स पॉसिबल सर. नेगेटिव वेरिएंस, इफ यू आर सीइंग डिस्टेंस ऑफ अ पॉइंट फ्रॉम इट्स मीन, सो ऑब्वियसली इफ फ्यू पॉइंट्स आर लेस देन द मीन, तो सर नेगेटिव तो आएगा. वी आर गोइंग टू गेट अ नेगेटिव वैल्यू, वी आर गोइंग टू गेट अ नेगेटिव वैल्यू. ओके, एंड इफ दे आर मोर देन द मीन, तो वी आर गेटिंग अ पॉजिटिव वैल्यू. ये होगा. तो वेरी तो नेगेटिव से पॉजिटिव कर ही रहा है, that is showing the variation. तो सर कोवेरियंस में भी कहीं whether we have to think of the feature means, कहीं ना कहीं feature means की बात कुछ हुई है क्या? feature means corresponding ले रहे हैं आप. देखिए इसका इसका जो फॉर्मूला है हियर, करा हमने वही है, वैल्यू माइनस मीन डिवाइडेड बाय टोटल नंबर ऑफ पॉइंट्स. कॉन्सेप्ट तो वही लगा है. ओके, वी आर यूजिंग द सेम कॉन्सेप्ट हियर, इट्स नॉट चेंज्ड. Value divided by its mean, value minus by mean and divided by the total number of points. Okay, तो पॉजिटिव नेगेटिव दोनों चीजें. अब नेगेटिव, हाँ, यस, एनीथिंग who want to say some
Sir, yeah,
some concept related to
it's
negative variance? Yes
no,
sir.
sir. It's like So it's like so when we take a normal probability curve,
Huh,
obviously
huh,
there is a mean,
huh,
and the first variance, that is one sigma, that is
huh,
plus or minus sigma, is
huh.
actually the variance from positive sigma to negative sigma
हाँ,
can
positive
happen.
sigma to नहीं, हाँ, हाँ, yes sir, absolutely
That
correct.
is the variance. Yeah, that is the variance.
Hmm,
So my question is here: if you say the variance of x,
hmm.
what is actually the mean then?
Variance of x.
Because we are comparing with y, right?
हाँ, हाँ, yes, comparing with y. Yes, I am
So
comparing
what
with
is
the y.
what is the mean? It's not the mean of the population. Is it the mean
It's a
of the
sample. It's
population?
a sample. Sample. It's a mean of
Sample.
sample.
So
Sample mean है. ये
mean
sample mean है.
sample.
Okay, so we are calculating new. Okay, and x bar is the okay. New is your population or sample. And what is x bar then? This means से इनका भी meaning होता है. Okay, new is related to population or sample. इनका
Population, sir.
हाँ
Population.
population. And x bar is your sample mean. X bar is your sample mean. Okay, so here we are calculating ये मीन यदि बात करें तो x माइनस एक्स बार वी आर कैलकुलेटिंग द मीन ऑफ अ सैंपल. ये भी टेक्निकल टर्म्स हैं. न्यू एंड एक्स बार टेक्निकल टर्म्स हैं. सो इन जनरल वी से न्यू एंड सिग्मा. सो सिग्मा स्टैंडर्ड डेविएशन एंड न्यू इज ये पॉपुलेशन के लिए बात कर रही है. एक्स बार की बात कर रहे हैं. सो एक्स बार इज योर मीन ऑफ अ सैंपल. और व्हेन वी आर गोइंग टू कैलकुलेट द वेरिएंस तो वो नीचे n माइनस वन कर रहा है. n माइनस वन. सो सच काइंड ऑफ फॉर्मूला वी सी इन ड्यूरिंग सैंपल ओनली. सैंपल का ड्यूरिंग कैलकुलेशन ऑफ द वेरिएंस कैलकुलेशन वॉट एवर. ओके, तो यहाँ n माइनस वन होता है और हमारे पास पॉपुलेशन में n माइनस वन नहीं होता. इन केस ऑफ पॉपुलेशन वी टेक x माइनस न्यू डिवाइडेड बाय x माइनस न्यू डिवाइडेड बाय n, कैपिटल n. वहां कैपिटल n लिखते हैं उसको. कैपिटल n लिखेंगे, नॉट n माइनस वन. ओके, ये
Sir,
चेंज.
in the
हाँ, इन दिस देयर इज अ
in
चेंज.
this in yeah no in this scenario, like we have a math that is x and science y.
हाँ,
So
हाँ,
the total population is six
हाँ,
data:
हाँ,
92, 60, 100, 80, 30, 70.
हाँ,
And when we say x distance,
हाँ,
the total population is 6, and the sample which we are taking is x, right?
हाँ.
So what will
Okay,
be the
now, okay, okay. See, you are having three student data currently. Okay, now population. What is population, sir? Population is 100 student data. For example, from 100 you pick data of 3 student, so it is a sample. Okay,
so
it's a
just a
sample.
sample?
It's a sample. So it's not like that 3 here and 3 here will total will gonna make us 6. So you are having a population 6. No, no. We are having population is a universal data. Okay, so we are considering everyone in a population. So it's a student. All the students for of a class will be considered as a population. Out of them, I pick 3 students. That will be called as a sample.
My actual question is like the way. So when we say the variance, which is the
Hmm.
distance from the mean
Hmm.
to that particular x.
To the
So this
particulars.
mean,
Huh.
yeah, this mean is not the mean of population,
No,
since
no,
we
sir.
don't know
No,
what
no.
is the
No,
mean
no,
of
no,
this
no. We
sample,
don't know.
right?
Yes, sir. We don't know. This is only sample
Uh,
mean.
okay, okay.
Okay, sir. We don't know
So
about.
it changes according to the sample. If
हाँ,
you
हाँ,
take a different sample, again
हाँ.
the variance
अब सर
changes for
उसके
that.
लिए हाँ सर, अब देखिए, अब आपने जो क्वेश्चन करा सर, वी डोंट नो व्हाट इज द पॉपुलेशन मीन, उसके लिए सर हाइपोथेसिस होती है. ओके, वी हैव टू अप्लाई कि ओके, कभी भी पॉपुलेशन इज अ बिग बिग टर्मिनोलॉजी सर. पॉपुलेशन इज अ बिग थिंग. सो वी डिराइव हाइपोथेसिस फॉर द सैंपल कि यदि फॉर एग्जांपल दिस इज द मीन, mean for 5 persons, for example. Okay, yeah, this is the statement which is derived over 5 people. Same statement will be derived for 5,000 people also. That's a hypothesis. Okay, and normally this kind of task has been done during survey. Okay, I will talk more about these concepts in my statistical part. Okay, तो जैसे हमारा ओपिनियन पोल होता है फॉर द इलेक्शन, सो नॉट सर सबको कंसिडर नहीं करा ना, उसने सैंपल ही लिया था. Okay, only sample of people, and they took 4,000, 5,000. And that's what I do explain to the every other student. In a city you might be having 10 lakh people, but the survey was done only over 5,000 people, and they told that this party is winning the election. ओके, सो ये तो सैंपल था, और सैंपल का ही मीन है। ओके, एवरीथिंग वेरिएंस और सब कुछ सब सैंपल का निकला। वी आर मेकिंग अ कंक्लूडरी स्टेटमेंट ओवर दिस सैंपल दैट पॉपुलेशन का भी यही यही ओपिनियन है, पॉपुलेशन इज ऑल्सो हैविंग द सेम ओपिनियन। ओके, तो दैट इज सैंपल एंड पॉपुलेशन का कॉन्सेप्ट।
Sir, yeah, what I'm saying, we have taken three sample, three student record right now as a
हाँ
sample,
हाँ, एज अ सैंपल।
and suppose it is 100 record, 100 students record are there. Suppose if I'm taking another 10 records as a sample,
हाँ हाँ
then the covariance changes, right?
हाँ, कोवेरियंस चेंजेस, यस, कोवेरियंस चेंजेस।
So,
ओके,
yeah. So how will you generalize that one to the PCA,
हाँ
like principal
हाँ,
component analysis, that
ओके
which
ओके,
sample should be taken?
हाँ, सी generalization will be according to our mathematical terms. We are going to generalize the same thing, और वही concepts यहाँ पर बोले गए। Nu is the mean of the population, x bar is the mean of the sample, n is the number of observations which you took in the data set, and xi is the observations which are present in the data set. Okay, as much
Mhm.
as data you are available. Okay, okay, and in our data set we do consider all the rows, not like only three rows and some only something only three rows we are not considering. This is a sample example, which sample hai ye कि just to make you explain what how I got the covariance, what is the formula for calculation of covariance. It's just a एक question I took टू एक्सप्लेन, एक क्वेश्चन बस सिंपल सा निकाला था मैंने टू एक्सप्लेन यू कि कैलकुलेट कैसे करते हैं। ओके, कोवेरियंस।
Mhm.
ऑलराइट, हियर आई टुक ओनली three data points. Okay, while applying the PCA you are having all the data points, all the data points will be present. ओके, तो वो सब पर लगेगा वो। इट्स नॉट कि सर आप वहां से कोई सैंपल पिक करोगे, इन योर डेटा यू आर हैविंग 100 पॉइंट्स और यू आर पिकिंग 10 पॉइंट्स फ्रॉम इट। नहीं, ऐसा नहीं करेंगे सर हम वहां पे। वी आर नॉट गोइंग टू डू
So
लाइक
that
दैट।
so that time
हाँ, population sir,
like
yes, yes,
population mean,
population,
yeah,
yes,
population
population
mean will be
will be
taken.
will be taken, population mean will be taken. Okay, new will be taken. So नीचे जो है वो -1 नहीं होगा सर, n-1 नहीं होगा, it will be capital N only, all the number of data
Mhm.
points, बस इतना ही चेंज
Okay.
आएगा सर।
Okay. Yeah.
All right, so this is
Thank
how this is how we are going to calculate the covariance. Okay, very very important, and not in hard and fast thing, but what is the idea behind it needs to be discussed, and we performed it. Okay, so once I'm getting the covariance matrix, I can find the your eigenvalue and the eigenvectors. So this is covariance matrix for 2 2. This is the covariance matrix for 3 3. Okay, we already checked. Okay, now now if you are having 10 dimensional data, yes, any doubt please? Yes sir.
यस सर। तो जैसे हम
Hmm.
वेरिएंस यूज करते हैं सर, वेरिएंस का एक पॉपुलेशन वेरिएंस है और एक सैंपल वेरिएंस।
Population variance and sample.
मैथमेटिकली हमें
हाँ, yes sir.
हाँ, मैथमेटिकली हमें जब कभी प्रेजेंट करना होता है, किसी रिसर्च पेपर में लिखना होता है, तो हम कौन सा फॉर्मूला कब यूज करें?
सर देखिए क्या होता है कि वहाँ वहाँ कौन से फॉर्मूला का यूज़ करना है सर, ये डिपेंड करेगा सर, डिपेंड करेगा आपके एनालिसिस पर। आइदर यू आर कंसिडरिंग द कंप्लीट डेटा एनालिसिस, इफ यू आर कंसिडरिंग द कंप्लीट डेटा एनालिसिस तो सर आपको पॉपुलेशन का यूज़ करना है, यदि कंप्लीट लिया। यदि आपने कोई सैंपल का यूज़ करा है, डेटा डेटा सैंपल, इफ यू इन जनरल ना सर हम ये बोलते हैं दिस इज जैसे हम एनालिसिस में सैंपल लेते हैं सर वैसे, ठीक है, दिस इज अ डेटा सैंपल वी से। ओके, ये सैंपल हमने लिया है, इसके ऊपर आपने एनालिसिस करा, तो सर आप वहां पर आप ऑब्वियसली आप जो है सैंपल मीन, सैंपल वेरिएंस वही कंसिडर करेंगे सर।
ओके
ओके, सो वो टर्म वो लिखता है बराबर इन पेपर एंड एवरीवेयर दे राइट्स दिस इज अ सैंपल डेटा। ओके, सो
यस यस यस
सर यदि आप तो सर आप सर यू आर सीनियर पर्सन, सो आपको तो आई थिंक पता है पहले से ही, और मतलब जो है, एंड बाय द हेल्प ऑफ यू देयर आर अदर पीपल आल्सो लर्निंग अ लॉट। ओके सर, तो आपका गाइडेंस है इसमें यहाँ सारी चीज़ों में, और आपका सपोर्ट भी है काफ़ी अच्छा, और मैं आपको अप्रिशिएट करूँगा इन बातों के लिए। एंड तो सर ये है कि सर की हेल्प से हम काफ़ी कुछ चीज़ें सीख भी रहे हैं, हमें पता भी रहेगा। ऑलराइट, तो एज पर द क्वेश्चन केम कि अपने रिसर्च में यू आर गोइंग टू टेक अ सैम्पल डेटा, तो सैम्पल डेटा में सर ऑब्वियसली वी आर गोइंग टू अप्लाई दिस फॉर्मूला. Okay, so sample mean, sample variance. Okay, sir. Any other doubt? Please let me know.
No, sir. Thank you.
Sir, when we have like one dimension, two dimension, and three dimension,
हाँ
how do you correlate this? Could
हाँ
you
हाँ हाँ
elaborate a
हाँ
little
हाँ
bit, sir?
हाँ हाँ सर, ये दैट्स व्हाट आई एम सेइंग सर. अब ये भी देखिए, अभी जैसे मेरे पास 10 डायमेंशनल डेटा है, 10 डायमेंशनल डेटा, and we are given with 10 principal components from it. 10 dimensional data का 10 principal components. Yesterday also I think Anil sir also asked the question yesterday कि सर कितना जो है, how much principal components we can make, max कितना बन जाएगा. So if you are having a 10 dimensional data, so max 10 components आप उनके बना सकते हैं, कम के लिए भी हम कह सकते हैं. ओके, सो 10 डेटा 10 कंपोनेंट्स देगा. सो पीसीए ट्राइज टू मैक्सिमाइज द पॉसिबल इंफॉर्मेशन इन द फर्स्ट कंपो. कोशिश ये करता है कि आपकी 10 कंपोनेंट्स वी आर प्रिपेयरिंग, सो जो पहला कंपोनेंट है, फर्स्ट कंपोनेंट, मैक्स इंफॉर्मेशन उस पर शो करी जाए, एंड ऐसा ही डिक्रीजिंग ऑर्डर में वो चलता है. द लास्ट कंपोनेंट, उस पर सबसे लीस्ट इंफॉर्मेशन शो होगी, लीस्ट इंफॉर्मेशन विल बी शोन. Okay, so these are the principal components. That means these are the vectors. These are the vectors over which I need to show the information. I need to show the variance of the data. Okay, so the first component is going to show the highest percentage of the variance. ये इस तरीके से variance define किया जाता है. Highest percent of variance. Okay, and I am teaching this algorithm in correspond to the application of your vectors and the matrices and the determinants and the eigenvalue, eigen vectors which we did studied. Okay, तो उसका ये application है, this algorithm. Okay, so if you are having 10 dimensional data, this is how we are going to show the projections. Okay, so highest variance will be explained at the component number 1 and so on, like this. Okay, so percentage of variance explained here, and इस तरीके से आप शो करेंगे. बट देर वॉज फ्यू मोर क्वेश्चन आस्क कि सर क्या हम पहुंच गए हैं, हैव वी रीच टू अवर पीसीए, इज दिस डन, you created this, you performed the standardization, you created a covariance matrix, then you applied the eigenvalue and eigenvector, you got it. Okay, then what are the next steps remaining? The next steps are feature vector and alignment of the data along principal components. So we need to align data along across your principal components. So feature vector, we need to calculate the feature vectors. Okay, तो अभी यहाँ तक तो पहुँच गया हम. We perform the standardization, we calculated the covariance matrix, we calculated the eigenvalue and the eigenvector. Now two step more remaining: feature vector calculation and align the data across the principal components. These two are still remaining. तो क्या करना है हमें, what next needs to be done? तो अभी जो left out questions हैं उनके भी I am going to answer. Okay, अब एक चीज है, after seeing this data we can say that sir, the variance or the features which are present about 6, 7, 8, 9 and 10 are less. ये तो बहुत ही कम इंफॉर्मेशन दे रहे हैं. सो सर वी कैन ड्रॉप देम, we are not interested in keeping them. However, the feature 1, 2, 3, 4 and 5 are showing high variance, high percentage of the data they are showing. So let's keep these features and rest I can drop. इनको कर दो. Those features which we are directly dropping but we are having a loss of information, अब इनका वेरिएंस ही कम है about this axis, about these vectors, तो इनको रख के अब करने का कोई मतलब नहीं है. We can drop it. This is the change which we brought via PCA. Okay, so 5 features can be dropped and rest we can keep. ये importance था PCA का. Okay, yes please say.
सर इसमें जो है कितने फी, कोई फॉर्मूला या कुछ थ्रेशोल्डिंग मेथड है जिससे कि हम ये आइडेंटिफाई कर सकें कि इतने फीचर्स को ड्रॉप कर सकते हैं
सर वो बता
या
देगा
डेटा?
आपको. हाँ सर, वही आगे थोड़ा सा और आई नीड टू एक्सप्लेन रिलेटेड टू द फीचर्स, वो बता देगा. जैसे जैसे सर ये देखिए, प्रिंसिपल कंपोनेंट्स और द आइगन वेक्टर्स रिप्रेजेंट द डायरेक्शन, ये तो डायरेक्शन मिल गया. सो आई एम हैविंग 10 डायमेंशनल डेटा, सो आई कैन से कि 10 डायरेक्शंस मुझे मिल गया. अबाउट दीज डायरेक्शंस आई नीड टू अलाइन माय डेटा, ये काम करना है मुझे. ओके, तो अब देखिए, these directions I got, these vectors I got, okay, in which the maximum information exists, ये बता देगा कि इसी दिशा में सबसे ज्यादा जानकारी है, इस दिशा में आप इस दिशा में चले जाइए, go in this direction and here the maximum information exists. Okay, all the principal components are perpendicular to each other. oh, अब ये क्वेश्चन मुझे पहले भी आया था कि सर आप एक्सेस हमेशा परपेंडिकुलर ही क्यों बनाते हो सर, आड़ी टेढ़ी क्यों नहीं बना देते. ओके, तो परपेंडिकुलर ही एक तरीका है हमारे पास टू मेक द थिंग सिंपल एंड रिप्रेजेंट द डेटा. हमने बचपन से लेकर आज तक परपेंडिकुलर एक्सेस ही पढ़ा है. ओके, तो अब हियर आल्सो दे आर सेइंग कि ऑल द प्रिंसिपल कंपोनेंट्स आर परपेंडिकुलर टू ईच अदर. ठीक है, नाउ द यूनिक कैरेक्टरिस्टिक्स दैट मेक्स ऑल द पीसी अनकोरिलेटेड, अनकोरिलेटेड, ओके, अनकोरिलेटेड, दैट ब्रिंग्स मल्टी कोलिनियरिटी, एलिमिनेट कर देगा वो मल्टी कोलिनियरिटी का. क्यों? क्योंकि जब परपेंडिकुलर होगा तो वन लाइन में आएगा नहीं, एंड वन लाइन में आएगा नहीं तो मल्टी कोलिनियरिटी इज ओवर. ओके, बिकॉज योर डेटा इज नॉट कमिंग इन अंडर वन लाइन, सो देयर इज नो मल्टी कोलिनियरिटी, ऑल एक्सेस आर परपेंडिकुलर टू ईच अदर. बात खत्म हुई, मल्टी कोलिनियरिटी वाला कॉन्सेप्ट ही खत्म कर दिया हमने. सो यही तो मुझे चाहिए था ना, data, that's what your model requires. The features should not be collinear neither correlated, that's what I require. So all these principal components are perpendicular to each other. I got 10 principal component, all are perpendicular to each other. Okay, and they are having the scalar values that they are called as eigen values. About करस्पॉन्डिंग है ये इनका, v1 का ये है, v2 का दिस इज द वैल्यू. यस, इफ नॉट परपेंडिकुलर देन इट कैन नॉट बी कोऑर्डिनेट सिस्टम. यस सर, ऑब्वियसली इफ इट इज नॉट परपेंडिकुलर वी डोंट हैव एनी कार्टेशियन सिस्टम. कार्टेशियन सिस्टम को डिफाइन करने के लिए ही यस यस.
No, what I mean is any coordinate system, whether it's Cartesian or r phi theta, it need to be perpendicular. Otherwise, you cannot define, because what will happen is if it's not perpendicular, then you can like what you said, linear dependence, right? So
linear,
you
yes,
can define. So you can define y-axis in terms of x if it's not perpendicular. That's what I mean.
तो ये this will be the issue. Okay, so that's why we make the things perpendicular. All right, तो I want axis x and y perpendicular to each other. उसके about हम जो है चीजों को डिफाइन करते हैं, वो प्रैक्टिकल भी है. प्रैक्टिकल सिनेरियो में भी हम इसी तरीके से ही डायमेंशंस को परपेंडिकुलरली रिप्रेजेंट करते हैं. सो सर आल्सो सेड कि सर वो कार्टेशियन सिस्टम में यही होता है, परपेंडिकुलर एक्सेस होती है. Okay, so we define everything perpendicularly. Now you are having lambda 1, lambda 2, lambda 3, all these things, these are the your eigen values. Okay, and eigen values ही आपका परसेंटेज ऑफ वेरिएंस या इंफॉर्मेशन एक्सप्लेन करती है अबाउट दीज वेक्टर्स, अबाउट दीज वेक्टर्स. ठीक है, ओके, तो टू कंप्यूट परसेंटेज ऑफ वेरिएंस by each component we need to divide eigen value of each component by the sum of eigen value. So one question अभी just recently मुझसे पूछा, सर बताइए कैसे पता लगेगा हमें. आपने you calculate 10 वेक्टर निकाल लिया आपने, आइगन वेक्टर 10 आइगन वैल्यू आ गई उनकी, तो हाउ आई एम गोइंग टू आइडेंटिफाई आगे क्या हो सकता है, व्हाट इज द पॉसिबिलिटी. तो ये फॉर्मूला आपको अप्लाई करना है. आई नीड टू कैलकुलेट द फीचर वेक्टर्स, फीचर्स निकालना है मुझे, फीचर वेक्टर निकालना है. तो देखिए क्या है, आई नीड टू divide, for example I got lambda 1 and lambda 2 as two eigen values. For example मेरे पास दो ही डायमेंशन थे. In case for example I am having two dimensions, so I will be getting two vectors v1 and the v2 which are perpendicular to each other, corresponding उनका eigen values भी आ रहा होगा. So the percentage of variance explained, percentage of variance explained by first principal component, that is your v1, is calculated by lambda 1 upon lambda 2, and the percentage of variance explained by another principal component is given by lambda 2 upon lambda 1 plus lambda 2. ये आ जाएगा, रेशियो लेना है आपको. सो टोटल नंबर ऑफ ऑल, जैसे अभी आपके पास 10 डायमेंशंस हैं, सो यू आर गोइंग टू टेक लैम्डा 1 प्लस लैम्डा 2 प्लस लैम्डा 3 अप टू लैम्डा 10. ओके, और हर एक का निकालो आप. लैम्डा 1 अपॉन द सेम, लैम्डा 2 अपॉन सेम, लैम्डा 3 अपॉन सेम, ये पूरा निकालिए आप और देखिए किसका कितना परसेंटेज आ रहा है. For example, lambda 1 is coming 1.8, lambda 2 is coming 0.49. If I'm going to find the principal components, 96% ये शो कर रहा है और नीचे वाला 4% शो कर रहा है. So 96% is a high variance. Okay, so I'm going to keep it. I'm going to keep it. Okay, I'm going to keep it. All right. And 4%, obviously this is less information. Okay, I'm going to drop it. Fine. Previously it was representing 10 to 15%. That is still a high value of the information. A 4% पे आ गया ये about this axis, about this principal component. अब I can drop it. इसको मैं निपटा दूंगा अब. So अभी क्वेश्चन पूछा सर कैसे आप how you are going to decide कि ड्रॉप करना है. ऐसे डिसाइड करेंगे सर हम कि हमें ड्रॉप करना है ये. About PC2 इतना आ रहा है. ओके तो PC2 इज योर वी सेकेंड फीचर का प्रिंसिपल कंपोनेंट था ये. ओके उस पर यदि प्रोजेक्ट करोगे दैट वैल्यू फॉर द सेकेंड फीचर उसको करोगे तो इतना हो जाएगा, वो इतना कम हो जाएगा, निपटा दो उसे, ड्रॉप कर दो. ओके नाउ तो 96% इज एक्सप्लेन्ड बाय PC1, 4% बाय PC2. ये निकला. अब देखिए फीचर वेक्टर. A feature vector is a matrix of all the eigenvector which we decide to keep column wise. Which we decide to keep column wise. So it is the matrix of all the eigenvectors. उसको column wise रखिएगा. Okay, keep it column wise ऐसा. ये feature vector कहलाता. यानी कि V1, V2, V3, V4, V5, V6, V7, V8, V9, V10. It's a column vector of all the eigenvectors which you have calculated. ऐसा मैट्रिक्स बन रही है इसकी. A feature vector is a matrix of all the eigenvectors which we decided to keep column wise. ये आपका feature vector कहलाता है. Okay, then next क्या है? Okay, तो for example you are getting m eigenvectors out of n. The final data will have m dimension. ठीक है, तो अभी आपने डिसाइड कर ही लिया कि how much we are going to keep. तो उतने फीचर आप सिलेक्ट कर लीजिए. फॉर एग्जाम्पल ये तो था 10 फीचर्स थे आपके पास. आउट ऑफ देम 5 फीचर्स आर गिविंग लेस इंफॉर्मेशन. वी कैन ड्रॉप इट. We can drop it. So I am left with only first 5 which are showing the high variance. So just keep it. We are going to keep it. Okay, so that will be representing the feature vector. Okay, then we can align it along the principal component. This is the formula. Feature vector ka transpose multiplied by standard original data. दिस इज योर ओरिजिनल डेटा का ट्रांसपोज करें, फीचर वेक्टर का ट्रांसपोज करें, मल्टीप्लाई करें. दिस इज योर फाइनल डेटा. दिस इज योर फाइनल डेटा. यस सर, प्लीज आस्क द क्वेश्चन. यस सर, प्लीज आस्क द क्वेश्चन. अनिल सर. Yes, any doubt, please let me know. Very, very important step.
Sir, yeah. Sir, I have a question. Like, this is a basic question. Something like, the PCA initially the axis in the perpendicular, that is vertical and horizontal line. Then we have twisted the axis like some degree, right? So both are perpendicular, keeping perpendicular. So now the angle of this vector, Euler vector, how we are just determining this direction?
Sir, angle of that, sir, in general, this algorithm is defined to get the principal components perpendicular only, sir, as we discussed that Cartesian system. Okay, that means we are actually presenting data perpendicularly. So for that regards, which I have solved here, there is nothing which we have included in any of the step where we are projecting to particular angle. सर कोई मैथ्स ऐसा लगा नहीं यहाँ पर जहाँ मैं उसको किसी एंगल वाइज कर दूं. और यदि एंगल वाइज हो गया, फॉर एग्जांपल एंगल वाइज हो गया, तो सर हमारा जो इशू था वो वो कोलिनियरिटी वाला. Okay, collinearity correlation.
No, sir. I'm not telling that one. The two features x and y are always
perpendicular. Yes.
But what I'm saying is that but when we throw a x, for example, we are drawing an x. The x line will have an angle with the horizontal. So after that, y is perpendicular to the x.
Y is
That's all right.
To x. Yes.
But x will have an inclination with the horizontal.
Yes.
So that inclination, how will you calculate that from the eigenvalues?
So that calculation needs to be checked how we are going to calculate it. क्योंकि मैट्रिक्स में और यहाँ तो हमने कोवेरिएंस ये सारा चीजें निकाल लिया. Yes, please say.
Because eigenvalue give the magnitude only.
हाँ
Like eigenvalue lambda
हाँ,
gives
it's a
the
magnitude.
magnitude of
हाँ
the value,
हाँ
but it's not giving any direction.
हाँ, डायरेक्शन नहीं दे रहा। अब सर देखिए क्या है, फॉर एग्जांपल डायरेक्शन तो सर आइगन वेक्टर से निकल रहा है ना, आइगन वेक्टर इज गिविंग द डायरेक्शन ना सर, डायरेक्शन तो यही है। दैट्स व्हाई वी आर
Yeah,
टेकिंग बोथ इन बोथ आइगन वैल्यू एंड डायरेक्शन बोथ। आइगन वैल्यू इज द परसेंटेज ऑफ वेरिएंस एक्सप्लेन्ड अबाउट दिस डायरेक्शन।
means xi cap plus yj cap. Do you mean that one is the vector?
हाँ एक्स, हाँ दैट्स अ वेक्टर, एक्स आई कैप प्लस वाई जे
Right.
कैप, एक्स आई कैप प्लस वाई जे कैप इज अ वेक्टर, इट्स अ वेक्टर। ओके
Okay,
सो
that gives the direction.
हाँ हाँ, ये तो वेक्टर तो आपका डायरेक्शन दे ही रहा है, दैट इज द प्रिंसिपल कंपोनेंट दैट इज गिविंग द डायरेक्शन। द आइगन वैल्यू इज अ स्केलर वैल्यू दैट इज शोइंग द परसेंटेज ऑफ द इंफॉर्मेशन अबाउट दैट पर्टिकुलर वेक्टर, द परसेंटेज ऑफ इंफॉर्मेशन या वेरिएंस एक्सप्लेन्ड अबाउट दैट वेक्टर दैट इज गिवन बाय द आइगन वैल्यू, ये दे रहा है सर।
Mhm.
ओके यस
Okay, okay.
यस यस, एनी कमेंट्स? प्रोजेक्शन, प्रोजेक्शन की बात कर रहे हैं, प्रोजेक्शन की बात कर रहे हैं। तो हियर the vectors which we are calculated from your covariance matrix, okay, that will be the projections, principal components will be the projections for them, जहां पर सबसे ज्यादा वेरिएंस एक्सप्लेन्ड है, which are present। तो अब आप क्या कर लें फाइनल में, फाइनल स्टेप में आप अपने डेटा को अलाइन कर लें अबाउट दोज वेक्टर्स। okay, this is your completed data, align your data about these vectors, अलाइनमेंट कर लीजिए आप। okay, this will be your final data, यही होंगे आपके पीसीए एल्गोरिदम का लास्ट स्टेप। ओके सो स्टिल वी गॉट टाइम टू, हम इसको और अंडरस्टैंड एक्सप्लोर करेंगे। अभी मैं इन जनरल ब्रीफ कर दूं आपको व्हाट वी डिड लर्न हियर इज, वी वांट टू सिलेक्ट द डायमेंशंस from the huge data set, okay, high dimensional data set. I need to find those dimensions which are relevant for me to use in a model. So I applied all these systems, standardization of the data to make all in a same scale. I calculated the covariance, okay, that means how these features are impacting on each other, तो impact पता चल गया। then next I applied eigenvalue and eigen vectors, कैलकुलेशन करा ताकि किस डायरेक्शन में मुझे प्रोजेक्ट करना है इस डेटा को, ओके, एंड एंड वैल्यू से आई कैलकुलेटेड हाउ मच वेरिएंस या इंफॉर्मेशन इज एक्सप्लेन। सो लैम्बडा सर जो आप बोल रहे हैं, जस्ट इट्स गोइंग टू टेल यू इट्स अ स्केलर वैल्यू बिकॉज वो रेशियो लिया है हमने आइगन वैल्यू से, जस्ट रेशियो है, इट्स इस वेक्टर का उस डायरेक्शन में कितना इंफॉर्मेशन मुझे मिल जाएगा, दैट्स व्हाट इट्स टेलिंग। तो वेक्टर्स तो अपना डायरेक्शन बता ही रहा है, लैम्बडा से जस्ट इंफॉर्मेशन है वेरियस कितना एक्सप्लेन होगा वो पता चल गया मुझे। okay, and then I calculated for all the dimensions by taking the ratio, जैसे lambda 1 upon lambda 1 plus lambda 2 upon lambda 1 plus lambda 2 and so on, I did this thing, all right। and then ये निकालने के बाद I found the feature vector, feature vector is a column vector of all the vectors, put it जो भी selected हुए हैं लास्ट में, यू सिलेक्टेड एम वेक्टर्स, ओके, जिनका वेरिएंस हाई था तो आपने उन 5 को सिलेक्ट कर लिया, उनका कॉलम वेक्टर बना दिया, एंड यू अप्लाई द ट्रांसपोज ऑफ इट मल्टीप्लाइड बाय योर इनिशियल डेटा या एक्चुअल डेटा का स्टैंडर्डाइज ओरिजिनल डेटा का ट्रांसपोज। ओके सो फीचर वेक्टर एंड स्टैंडर्ड डेटा ट्रांसपोज, दैट्स व्हाट यू डिड, ये आपका फाइनल स्टेप है, दिस इज अ फाइनल डेटा। ओके सो डजंट मीन मेरे पास न्यूमेरिकल भी है, I will be solving numerical in front of you, क्योंकि sir these are the steps which we have learned but we want to see it mathematically, कुछ numerical solve कर दीजिए सर इस पे। okay so we'll be solving numerical for it, we will be deriving this algorithm also over Python, ये भी करेंगे हम next class के अंदर, we'll do that, okay, any doubt please let me know। yes sir।
So we'll write a class for PCA. That's what you were saying.
हाँ PCA sir, we are going हाँ, so we will be sir doing the code also for the PCA, okay, so sir but that means without using the PCA algorithm, that means directly importing, let me show you, without importing the PCA we are going to whatever be the maths which we have learned, we are going to implement it here on the Python, data standardization, calculation sir of covariance, eigenvalue eigenvector calculation, then calculating the components feature matrix, okay, and then You are going to project your data over the feature matrix. That's what we are. This is the code which I will be explaining. और ये आपको अब पता चल गया, जब आपको algorithm पता चल गया, you know it कि सर क्या होने वाला है. So I haven't imported any PCA. नहीं लगाया मैंने. And I performed. This is my original data and this is my reduced dimensional space. ये PCA से मुझे मिला है. And if I'm going to use PCA, I can do that. From sklearn decomposition, import PCA. You can do whatever be the task I did directly. Yeah, yes, sir.
Yeah, so I mean, I just want to, I mean, I know how PCA works, but I just wanted to learn object-oriented programming from what I know. That's what my
Sir.
intention is.
Sir, this is the way, sir, we are going to do the code.
So here you are using all the functions, right?
All
so
the
what
functions.
I was expecting is a...
Okay, so
yeah,
you
so can we write a class?
Class. Okay, fine, sir. Done. Okay, I will make a class, sir. Okay, sir, I will make a class.
So then, because, yeah, thank you.
Okay, sir, I will make a PCA class and then there I will call the methods. I will create an object and I will call the method. बस इतना हो जाए, class बन जाएगी, उसके नए methods को call कर लूंगा मैं उसकी help से, object की help से.
Somehow I find that too abstract. That's why I'm asking. Thank you very much.
Okay, sir. Yeah, sir, I will convert this code into class format, sir. Okay, so implementation we are going to check for the PCA. That we will do. Okay, sir. All right. So let me stop the record.